Bismillahirrahmanirrahim. Assalamu alaikum and hello to all and welcome to Biosciences with Shatreen Sawati. And Shatreen Sawati is here to deliver the lecture from my next series, and that is about the biochemistry. And today I will deliver my first lecture from biochemistry, and that lecture is about the carbohydrate. So before starting my lecture, I request to all of you, if you did not subscribe my channel, do subscribe my channel, like my videos, share my videos. If you are sharing my videos, my lecture, you are sharing the knowledge. So keep watching, keep sharing knowledge with others. So all those students who requested me to deliver the lecture from biochemistry, hold on your notebook and note down all the important information which I'm going to deliver you people. So in this lecture I will discuss first introduction, then classification, then stereoisomerism, little bit about the stereoisomerism in monosaccharides, because I want to clear the concept about the stereoisomerism in monosaccharides. And then at last I will discuss about the importance of the carbohydrates. So first of all, what are carbohydrates basically? We are taking the carbohydrate as a diet in different form, in our breakfast, in our lunch, in our dinner. So what are carbohydrates? A carbohydrate is a biomolecule. You know that biomolecule, and consisting of carbon, hydrogen and oxygen atoms, usually with a hydrogen oxygen atom ratio of 2:1, and this ratio is same as in water, and thus with the empirical formula CmH2O whole n. As you can see, this is the empirical formula, and this is the ratio, which is hydrogen oxygen ratio, same in the water. In scientific literature, the term carbohydrate has many synonyms like sugars, saccharides, saccharose, glucide. Hydrates of carbon are polyhydroxide compounds with aldehyde and ketones group. I will show you some of these terms, especially carbohydrate and sugars, are also used with other meanings. Is it clear? This is the little bit information or introduction to the carbohydrate basically. Now I'm going to discuss about the classification. What are the most important classes or types of carbohydrates? Carbohydrates are divided into monosaccharides, oligosaccharides, disaccharides. Disaccharide is the subtype of the oligosaccharides, and polysaccharides, and at last complex sugars. So monosaccharides are those which cannot be hydrolyzed. They are the simplest unit, or you can say that the building blocks. Monosaccharides are the building blocks of the carbohydrates, all the carbohydrates like oligosaccharides, polysaccharides, complex sugars. So, what are the oligosaccharides? Oligosaccharides are composed of 3 to 10 monosaccharides units. And on hydrolysis, they give rise 3 to 10 monosaccharides. So, disaccharides, which are oligosaccharide, consist of 2 monosaccharide units. How many? Di mean 2. So, consist of 2 saccharides, 2 monosaccharides units. Monosaccharide single, which is the building block of all the oligopolysaccharides, disaccharides. So disaccharide, di means 2, saccharides means sugar, so consist of 2 monosaccharides. And on hydrolysis, the disaccharide give rise 2 and oligosaccharides give rise 3 to 10 monosaccharides. Similarly, poly means many. So these polysaccharides, which are the most important class of the you can say the carbohydrates, this on hydrolysis gives 10 or more monosaccharides, and I will explain all these with the help of examples step by step. So complex sugars are on hydrolysis give a sugar molecule and non-sugar molecule. I will discuss what are the complex type, like many simply you can say that the complex sugar contain, I'm giving you example like glycoproteins, glycolipids, all these are the complex types of the sugar. Okay. Now, first of all, I'm giving you information about the monosaccharides. As you people are familiar with the glucose, fructose, galactose, these are all the monosaccharides and all consisting of 6 carbon atom, and their simplest formula, molecule formula, chemical formula is C6H12O6, because all these monosaccharide consist of 6, as you can see here, 1 2 3 4 5 and 6 carbon, like 1 2 3 4 5. This is the fructose, and 6, 1 2 3 4 5 and 6, 1 2 3 4 5 and 6. Is it clear? This is glucose, fructose and galactose, simplest monosaccharides. Now, what are monosaccharides? Monosaccharides have 3 to 7 carbons, have either aldehyde group, some monosaccharide contain aldehyde group, aldose, or some contain the ketone groups known as ketose. Aldehyde group containing are known as aldose, and ketone containing groups are known as ketose. Have hydroxyl group on every carbon except carbonyl carbon. Except the carbonyl carbon, which is also known as anomeric carbon 2. Now, aldoses and ketoses, monosaccharides are of two types, aldoses and ketoses. Aldoses contain the aldehyde group and ketoses contain the ketone group. Now, this is the aldehyde group. C double bond O H. COH. Simple aldehyde formula is COH. And the ketone formula C double bond O, with 2 alkyl group, 1 2, and this is the central carbonyl carbon with oxygen. Here 1 hydrogen and 1 alkyl group, and this is the oxygen. So this is the aldehyde group, this is the ketone group. So aldehyde containing monosaccharides are known as aldose, and ketone group containing carbohydrates are known as ketose. Okay, I hope so the concept will be clear upon you people. So this is the, you can see here glucose and the fructose, both 6 carbon containing molecules, biomolecules, and monosaccharides. They are simplest monosaccharide. This is the glucose, this is the fructose, and you can see here the difference. In case of the glucose, you can see this is the aldehyde group, and in case of the fructose, there is a ketone group. So fructose is ketose and the glucose is aldose. Now the concept is more clear upon you people, that how if the aldehyde group is present, then the biomolecule is known as monosaccharide, or biomolecule is known as what? Aldose. And if there is a ketone group, that there is known as ketose. Okay. Here you can see different example: glucose, mannose, galactose, fructose. All these are what? All these are what? All these are different types of the monosaccharides. Glucose, mannose, galactose, fructose. Is it clear? All these are, you can say, these are the simplest and 6 carbon containing monosaccharides with aldoses and ketoses. Aldose mean aldehyde containing. All these are aldehyde containing. Like glucose, must keep it in your mind. If you have to solve any MCQ, you must keep it in your mind that the glucose, mannose, galactose, aldehyde containing monosaccharide, and the fructose is ketone containing monosaccharide. Is it clear? Okay. Now the classification of the monosaccharide. Monosaccharides are further classified into trioses, tetroses, pentoses, hexoses. Is it clear? Trioses with 3 carbon, like glyceraldehyde. This is the 3 carbon. Dihydroxyacetone, acetone, dihydroxyacetone, this is also the 3 carbon. But the difference in between the glyceraldehyde and dihydroxyacetone is both 3 carbon, but the glyceraldehyde and dihydroxyacetone is the ketose. Now tetroses with 4 carbon. Example, erythrose and erythrolose and erythrose. One is aldehyde, other is the ketone. Pentose is the most important. Pentose, you people are familiar with the ribose, which is the part of the ATP, DNA, RNA. So this ribose is very important building unit in all the polynucleotide, which is the polynucleotides are complex. You can say that forming the complex with other nitrogenous bases and phosphate. So pentose is 5 carbon containing monosaccharides like ribose and ribulose. Is it okay? I must give you ribose is aldopentose and ribulose is ketopentose. This is the ketose, this is aldo. Now concept is clear upon you people. Now hexoses, the most important hexoses: glucose, galactose, mannose, fructose, and you people are now familiar. Glucose, galactose, mannose are aldehyde containing groups, monosaccharide, and the fructose is the ketone group containing monosaccharide. So all these you can see here on the screen, different types of the monosaccharides with their functional group. Is it clear? Okay. Now I'm going to discuss a little bit about the stereoisomerism in monosaccharides. What is basically, now I'm going to discuss what are isomers, diastereoisomers, and epimers in monosaccharides. First of all, the isomers. Iso means same, mers mean parts or fragments. So compounds that have the same chemical formula but with different structures. I will show you. Same, like you can say that C6H12O6. This is the monosaccharide, 6 carbon containing hexose sugar. So this hexose sugar C6H12O6 is applicable to glucose, galactose, mannose, fructose. All are 6 carbon containing, but you can see here they have the same chemical formula but with different structures. How? Fructose, glucose, mannose, galactose, and all are isomers of each other, having the same chemical formula but different structures. Okay. Now what are the diastereoisomers? Diastereoisomers have different arrangement of the hydrogen and hydroxyl group at more than 1 carbon and are not mirror images of each other. How many? Have different arrangements of hydrogen and hydroxyl at more than 1 carbon. You can see here. Now this is the, you can say that the functional group, aldehyde group, and the carbon is the carbonyl carbon. Now you can move here. You can see carbon number 2, 3, 4, 5 and 6. You can see the different arrangement of the hydrogen ion and hydroxyl ion at more than 1 carbon. Like here is hydrogen present, here hydroxyl, then there is hydrogen, and so on. So different arrangements of hydrogen and hydroxyl ion more than 1 carbon. Okay. So epimers, what are epimers? Epimer carbohydrate isomers that differ in configuration. About only specific carbon atom, with the exception of the carbonyl carbon, are defined as epimers of each other. What are epimers? The carbohydrate isomers that differ in configuration around only one specific carbon atom. Just one carbon atom, around one carbon atom, there is a differ They are different configuration and are defined as epimers of each other, except the carbonyl carbon. Now, glucose and galactose are C4 epimers. I will show you. As a structure differ only in the position of hydroxyl ion at the carbon number 4. Now, you can see here, like glucose and galactose, which are C4. C4, glucose, this is glucose, this is galactose. And you can see here at carbon number 4, there is, in case of glucose, hydrogen ion is present on the left side and hydroxyl ion present on the right side. But in case of the galactose, you can see hydroxyl ion is present on the left side and hydrogen ion is present on the right side. So they are different, glucose and galactose, they are epimers of each other because they are different at carbon number 4. Similarly, you can see here mannose. Mannose is different at carbon number 2 from glucose. You can see here hydroxyl ion is present on the left side and hydrogen ion here in glucose is present on the left side. So at the 2 carbon atom they are different. Is it clear? The concept of epimer is clear now. What are epimers? Which are different at arrangement or configuration around one specific carbon. Exception is the carbonyl carbon. This is the carbonyl carbon, which is the carbon of the functional group. Is it clear? Okay. Now I'm going to give you information about the enantiomers. Like you can say that epimers, you see diastereoimers, which are not the mirror images of each other. Now in case of the enantiomers, a special form of the isomer or isomerism is found in pairs of structures that are mirror images of each other. Enantiomers are what? They are mirror images of each other. These mirror images are called enantiomers. And the 2 members of the pairs are designated as D or L sugar. D for dextrorotatory and L for levorotatory. And I will give you the concept of the dextrorotatory and levorotatory sugars. But most sugars are dextrorotatory. Is it clear? So what are the enantiomers? These are special isomers which are mirror images of each other, and the 2 most important members of the enantiomers are D sugars and L sugar. D for dextrorotatory and L for levorotatory. Okay. In the D-isomeric forms, hydroxyl group on the asymmetric carbon, what is asymmetric? A carbon linked to 4 different atoms. Furthest from the carbonyl carbon is on the right side. What? In D-isomer form, hydroxyl group present on the right side, furthest from the carbonyl carbon. While in the L-isomer, it is present on the left side. Must keep it in D. In case of the D-isomers, hydroxyl group present on the right side. But in case of the L levorotatory form, the hydroxyl group is present on the left side. I will show you in the figure. Enzyme known as racemase are able to interconvert D into L and L into D forms. Is it clear? Okay. Now you can see here, the dextrorotation refers to the clockwise or right-handed rotation. Dextrorotation is what? Right-handed rotation, clockwise. Like clock move. This is the clockwise. So levorotatory refers to the anti-clockwise or counterclockwise or left-handed rotation. Concept clear now? What is the difference between the dextrorotatory and levorotatory? And this dextro and levorotatory sugars are because of the hydroxyl group which is present on the right side in D form. Now you can see here OH is present on the right side in the D form. This is dextrorotatory glucose, and OH present on the what? right side, but in the lever rotatory hydroxyl ion present on the left side, furthest from the or away from the carbon on the right side. The concept clear? How the carbon, what is carbon, and what is the position of hydroxyl ion in dextro form and in the levo form, and what is dextro rotation? This is the right-handed or clockwise rotation, and what is the levo rotation? This is the anti-clockwise or counterclockwise or left-handed rotation. Okay, this is optical rotation. These all dextrorotatory and lever rotatory are the optical rotation of the plane polarized light. A chemical compound showing dextrorotation in a polarimeter from the perspective of the observer. The plane is rotated to the right clockwise. This is how the sugar molecule, which is dextrorotatory, move in the polarimeter. Is it clear? Now I hope so the concept will be clear upon you people about the dextrorotatory and lever, because most of the students confused about dextrotation and lever rotation and what is that and how. So now I have tried my best to convey the knowledge about the dextrorotation and lever rotation or D or L sugar of monosaccharides. So cyclization of the monosaccharides. Less than 1% of the monosaccharide with 5 or more carbon exist in the open chain form, acyclic form. About 1% exists in the open chain or acyclic form. The majority are predominantly found in a ring cyclic form, in which the aldehyde or ketone group react with hydroxyl group on the same sugar. I will show you how. The ring form as well as the open form or acyclic form. Now here I'm giving you the concept of the carbonyl carbon or the anomeric carbon. Anomeric carbon is basically the carbon-carbon. Cyclization creates on anomeric carbon and the former carboxyl or carbonyl carbon. Anomeric carbon is the carbonyl carbon. Okay. Now alpha D-glucose and the beta D-glucose are dextro, D for dextrorotation and L for the lever rotation. So dextrorotatory, cyclic and non-cyclic are cyclic or acyclic, ring form, open chain form. Okay. Now I'm going to show you. You can see here the simplest open D-glucose, dextrorotatory D-glucose in the mid. Okay. Now this is the simple acyclic. And then it become the cyclic form. How? How it become the cyclic form? You can see this is the OH group at carbon number 1, 2, 3, 4, 5. At carbon number 5. The ring is produced by the reaction or by joining the carbonyl carbon with the carbon number 5 of the same sugar. Now this H move towards this O and produces the OH, and this O form the bridge for the cyclic form of the sugar. Is it clear? How you can see here, like the ring form is produced in which the aldehyde or ketone group react with the hydroxyl group on the same sugar. Now in this case you can see here the aldehyde group. This is maybe the if in the case of the fructose this is the keto group, and in case of the glucose this is the aldehyde group. So aldehyde group react with the OH of the same sugar on carbon number 5 and produces the cyclic form of the D-glucose or ring form of the D-glucose. Okay. Concept clear? How the carbonyl carbon of the functional group attach with the carbon number 5 of the same sugar by forming the bond between this carbon and the carbon number 1 and carbon number 5 by the removal of the hydrogen ion, and then moving this hydrogen ion to react with this oxygen and produce an OH, and the ring is produced. So all the oxygen and hydrogen atom number do not change. Is it clear? Okay. So the monosaccharide cyclization is represented by Fischer projection formula structures and Howard projection formula. Number one is the Fischer projection. What is Fischer? This is the two-dimensional presentation of the ring. I will show you. Fischer is the two-dimensional, but Howard projection formula is the three-dimensional representation of the ring structure. Now Howard projection formula exists in two forms, cis form and trans form. Cis mean on the same side, like hydroxyl. You can see here cis form and trans form. In trans form, trans mean different, mean hydroxyl group and this CH2OH group present on the different sides. But in case of the cis form, this OH and this CH2OH group present on the same side. Cis same, trans different. I will show you here. This is a simple modified Fischer projection. This is the simplest, which is two-dimensional. But if you move towards the Howard projection formula, this is the trans. And you can see here, after cycling, what will happen? CH2OH and OH, this is carbon number 1. And this carbon number, this is H and this is OH. Okay. So CH2OH present on one side and OH present on the other side. So this is that mechanism in which you can say this is a transform. This is what? This is the transform in which CH2 and OH are on the different sides of the D-glucose, and this is alpha. So in beta case, must keep it in your mind. In case of the alpha is the transform of the sugar in which CH2OH and OH group are present on the different side of the molecule. But in case of the beta D-glucose, what will happen? CH2OH and OH present on the same side. Cis on the same side, trans on the different side. So beta is, in case of the beta, OH and CH2OH present on the same side, and in case of the alpha, CH2 and OH present on the different side. So this is the cyclic form of the Howard projection, which is three-dimensional, and Fischer is the two-dimensional. Now you can see here the clear difference between the Fischer projection and the Howard projection. Okay. Now oligosaccharides. What are basically oligosaccharides, which contain 3 to 10 or 3 to 9 carbon atom, and disaccharide is one of the most important form of the oligosaccharide. And disaccharides examples are lactose, sucrose, maltose. Lactose is present in our in the milk, and the sucrose is present in the table sugar, and the maltose is present in the malt. So lactose is produced by the condensation of the glucose and galactose. Must keep it in your mind. The mechanism of condensation and hydrolysis are the two important chemical reactions. In condensation, monomolecules. Monosaccharide is the micromolecule or monomer, micromolecule. These macromolecules combine by condensation to produce the macromolecule. So by condensation, lactose is produced, and the condensation of what? Glucose with galactose. Must keep it in your mind if you have to solve the blanks MCQs. So must keep in mind how the lactose is made up of the glucose and galactose. Sucrose produced by the condensation of glucose and fructose, and maltose is produced by the glucose and glucose. And on hydrolysis, lactose give rise galactose and glucose. On hydrolysis, sucrose give rise glucose and fructose. On hydrolysis, maltose give rise glucose and glucose. The concept is clear about the disaccharides, where they are present, and what are the chemical formula and structure of the sucrose, maltose, and lactose. Okay, this is lactose and showing 1,4. Now, what is the glycosidic linkage or glycosidic bond? The two monosaccharides, which are the simplest form of the carbohydrate, are the building block of the carbohydrate, two monosaccharide. You can see here, in case of the maltose is made up of two glucose molecule. So when maltose is made up of two glucose molecule. So when two glucose molecule by the condensation combine with each other by the removal of one water molecule, here what will happen? The bond is produced between the carbon number 1 of one monosaccharide or glucose and the carbon number 2 of the other glucose molecule. Is it clear? One glucose molecule, carbon 1, form the bond with the other oxygen, molecule, other carbon number 4 of the second glucose unit, and this type of the bond is known as glycosidic bond. And glycosidic bond in case of the disaccharide is 1,4, but in case of the polysaccharide you will see 1,4 as well as 1,6. And 1 and 4